Welcome to the Design World webinar, Sensing Trends in Industrial Applications, sponsored by MTS Sensors. I'm Randy Frank, Senior Editor for Design World and the Sensor Tips website. I am an organizer and moderator for today's session. Before we start, though, a few housekeeping items there. This webinar will be available afterwards at designworldonline.com and through email. We're going to have a Q&A at the end of the presentation, so as the speakers talk, make sure you put your questions together and save them till the end, where we'll open it up there for those questions. And again, the hashtag for this webinar is #DWWebinar. With that, we'll have a little bit of introduction of who the players are today. Again, I've already explained who I am, but our first speaker is going to be John Schnell, who is a Senior Application Engineer at FoodTech Advanced Sensor Technology. John has had over 30 years of direct experience working with sensors that are utilized across the test and measurement markets. Currently, he's involved in a large number of OEM ventures, serving as project manager and industry expert. And as the head of the Columbus, Ohio facility, John is also involved in the direct support of FoodTech's Midwest customers and the development of their technical representative sales team. Our second speaker is going to be Brian Clothier, who's shown in the third position here. Brian is the co-founder of what is now TSI Technology, and he currently serves as the CEO there. Over the past 17 years as president or CEO, Brian has been the inventor of over 20 U.S. patents and many foreign counterparts. He's a former Air Force instructor pilot, has attended UC Berkeley, the U.S. Air Force Academy, and the University of Texas at Austin, and holds undergraduate degrees in mathematics and physics and a master's degree in physics. Clothier has won a complete work on National Science Foundation Phase 1 and Phase 2 grants for his microwire temperature sensing system that we'll hear more about later. And finally, our third presenter is going to be Todd Hansen, Director of Wireless Solutions for Honeywell International, Inc. Todd is the Director of the Strategic Marketing and Wireless Solutions in the Sensing and Control area. In this role, he's responsible for the Sensing and Control's wireless solutions, as well as the overall Sensing and Control industrial business. He actively collaborates with other automation and control solutions businesses to formulate a one Honeywell strategy where Sensing and Control supports the other businesses to help drive total Honeywell solutions. Now, the way we're set up here is that each presenter is going to address a specific trend in industrial sensing. For example, there's a trend toward non-contact, non-wear sensing that's driving the increased use of magnoresistive technology for sensing. Magnetostriction has been used for decades now to provide linear position feedback in a variety of applications, primarily inside hydraulic cylinders, but advances in the performance, housing options, and electrical interfaces have expanded the range of applications suitable for this technology. The specific reason for switching to magnetostriction often depends on the current technology the customer uses. That's the kind of background that we're going to hear from as the trends are identified there. And again, our speakers today have identified 3 different trends. I'll let them say is what they do. So without any further ado, let's get the session started officially with you, John.
All right, very good. Well, good afternoon. Again, my name is John Schnell. I am with FoodTech. FoodTech has 25 years of experience as a sensor manufacturer based out of Irvine, California. Quality is our #1 focus and our highest priority. As you can see from the first slide, this is supported by the certificates that we hold in various ISO areas. Our product catalog consists of load cells, reaction torque, rotary torque, pressure transducers, force sensors, multi-axis sensors, and instrumentation. In the instrumentation product line, we offer both digital and analog solutions. The topic for today's discussion is the utilization of USB and how that applies to the sensor world and data acquisition world. When I talk about data acquisition today, I was simply referring to general data acquisition, avoiding any specific or high targets such as extreme temperatures or extreme environments for data acquisition. If we look at the history, we see a clear division where sensor manufacturers developed products with analog outputs, and there was very low regard for the challenges as to how these signals were processed and the challenges that the data acquisition world had in terms of working with these signals. The same was true from the data acquisition world perspective, in that sensors were viewed strictly as commodities with a very little regard to performance and durability. This situation continued for many years, where, at least from my perspective, the sensor manufacturer and the data acquisition manufacturer were somewhat isolated from each other as working partners. From time to time, sensor companies would make an attempt to offer a digital output, possibly RS-232, RS-45, or others, as intermediate steps towards a digital solution. But at the same time, the marketplace really did not support this. When you look at the test and measurement marketplace, still very much analog. And the other part of the early offerings on the part of sensor companies for digital solutions was availability of software and solving that software issue. So the easiest approach for most of the sensor companies were to continue down the analog path, offering analog solutions and making that the de facto standard for most of the test and measurement environments. And this trend continued for a number of years. One of the best things I think that ever happened to the sensor world was the introduction of the personal computer introduction of the personal computer as a tool in the test and measurement world for data acquisition, offering a cost per channel step change, allowing test engineers to, for the first time, take points of measurement for a very low cost per channel situation. This provided increased use of sensors and also drove for a more common platform. Part of that evolution, as far as the use of the PC for data acquisition work, was the introduction of the USB output. Once the USB was introduced, as we all experienced in our personal lives, we now had a truly universal plug-and-play solution for all our devices, which most of us who use cameras and other things like that were thrilled with the results. Same thing applies to the sensor industry, in that we now had a common platform and a common language that allowed us to provide more of a relationship between the sensor world and the data acquisition world. And so a trend was occurring, and a few companies, QTech being one of them, decided to embrace this new technology and start down the path of USB to provide both hardware and software solutions for a total plug-and-play turnkey solution. Early USB solutions were slow, limited to typically 100 samples per second, and the resolution was also limited. But the focus was on standardization. There now was a platform that supported a standardized signal, standardized wiring codes, and standardized connection. The USB brought both the sensor world and the data acquisition world together so we could coexist in relative ease. When you look at some of the USB solutions that QTech offers, now, and you look at where we are today from where we've come from, you'll see that in terms of resolution, we offer 24 bits of capability, sample rate currently up to 15,000 samples a second. Both of these parameters meet or exceed the capability of the sensor. So we have capabilities that exceed performance of our sensors and provide a nice common platform for data acquisition. The USB 220 in our product offering will support both millivolt input at 4,800 samples a second. The USB 210 millivolt input at 1,000 samples per second. Our USB 320 is available for amplified signals, supporting both voltage and current inputs. And the USB 410 will work with our rotary solutions, providing input capability for millivolt as well as pulsed input for the encoder for rotary position and or speed. FUTEC has also taken a proactive position as far as software development. The FUTEC Sense-It software supports all our USB devices as well as our standard instrumentation line, which offers a USB output. In our most recent instrumentation solutions, we've continually increased our resolution, continually increased our samples per second, and that trend will continue. Our goal is to take this standardized platform and continue to enhance the product line, offering additional hardware for the marketplace. The Sense-It software will support up to 16 channels of USB input, which not only displays the data, but also allows for live graphing. It will capture the data and send the data to an Excel spreadsheet. So when you look at the capability of the Sense-It software, again, we offer a complete turnkey solution, but if additional capabilities are of interest to the user, we also support the LabVIEW programmers as well as the programmers. So that's our overview on USB capability and our platform that thank you leverage the technology and develop the standard. We thank you for your attention today, and we look forward to your questions at the end of the session.
Well, John, thanks a lot for that one. That gave us a great input on the trend there that obviously is very important to the sensing as well as to the desktop computing industry. Next up today is Brian Clothier from TSI.
To organize this talk, I'm going to talk very briefly about who TSI Technologies is and talk about two different technologies. The first, the microwire temperature sensing system, and number two, an eddy current thermometer. So first of all, who is TSI? We are not a manufacturer. We are an IP, product development, and engineering design firm. So our mode is to invent, patent, license, and then assist our licensees to market. And we play in the temperature sensing and control technology area. And of course, we're going to discuss a couple of those products today. We do have experience over 17 years helping our licensees get products to market. Our licensees control the fast food delivery world in the market, in the world market. Believe it or not, people like McDonald's do deliver overseas almost everywhere. BK, Pizza Hut, all those people. We have other food service and healthcare products that all are directed toward controlling temperature of some product, food particularly. And then we have two temperature sensing licensees in the microwire area, one for rubber processing and one in aerospace for curing composites. So let's talk about microwire temperature sensing systems. First of all, everybody's probably familiar with RFID, so I'll talk about the similarities. The components of this system are similar to RFID in that there's a reader. There is an antenna. In this case, the current readers are 4-channel. So there's one antenna per sensor in this system. There is a sensor, and we'll call this a magnetic temperature sensor, an MTS. It is designed to be molded permanently into the object, and it is very small, as we'll get to. And then, of course, there's some kind of a host computer, or the software can be moved into a reader micro. Okay, so why should you care? Why not just go with RFID? For one, these sensors, these MTSs, can be read remotely through conducting materials. That's why they're of interest to the aerospace and the rubber processing, particularly tire manufacturing markets at the moment, because they can be embedded beneath multiple layers of carbon fiber or steel tire belts and still be read remotely by their antenna. Also, they're so small that they don't constitute a part flaw because they're designed to be permanently embedded. They're in the form of a 9,000th diameter tube. Actually, that should be another 0 there. Sorry, and they're 1 inch long, and they are very robust. They can survive the tire molding process and curing process in autoclaves under high pressure. So they have certain features. One is this is a process sensor. It's not something that you would go and just point a reader at and read at any time. This is made to be a process sensor. So we assume that this sensor is embedded in some position where actual temperature cannot be measured by another sensor. Otherwise, it's really of no interest to our customers. This, for instance, put into a tire during its manufacture where you can't put a thermocouple, which would cause a flaw in the tire. So there really is no way to know the exact starting temperature. Therefore, these sensors are made to be self-calibrating during the process. They are also nonlinear temperature accuracy because closer to their Curie temperature, which is their ultimate service temperature, they are more accurate. Also, because there are multiple samples needed to be taken of these sensors to get the temperature, the polling rate is once per second. The basic theory of this sensor is that we're measuring the normalized saturation magnetization. There are actually 3 microwires inside the tube, which is 9,000th of an inch diameter. And each of those sensors exists only in 2 magnetic states. They're bistable magnetically. And when those sensors are interrogated by an external magnetic field, these wires change polarity. And when they change polarity, they emit a perturbation of the field, which we detect by the receive coil of the antenna as a voltage pulse. This is in the high microvolt range, and that pulse has a known dependency upon temperature. The calibration of this sensor is, like I said, is done during the process by one of the 3 wires whose known Curie temperature allows or is positioned so that that sensor disappears at a low temperature point in the process, and when it disappears, we then calibrate the other wire, which is used for sensing thereafter. I talked about the voltage pulses. You can see on the left-hand slide there are, that's a full phase picture of one phase of the magnetic field that's interrogating, and you see that at low temperature you have 2 pulses on each half of the waveform. As you get higher in temperature, the leftmost pulse starts to decrease in area, and we integrate those pulses, and we find that when the auto calibration sensing wire disappears, we see an inflection point on the left-hand pulse, which calibrates the sensor. And the right-hand pulse never changes, and it's used as a normalization pulse to eliminate distance dependence. Here's the representative results in a long autoclave cure. It's difficult in this picture to see because of the size, but there is a small bump that you can see around 60 C where the auto calibration took place, and there is a thermocouple behind the slightly more jagged signature of the microwire. As I said, the microwire is more accurate, closer to Curie, and there's also less dither in the signal because the changes in magnetic saturation per degree C increase as you get closer to Curie. Here's a representative use of such a sensor, and that's tire curing. So this sensor is embedded during the green tire layup near the shoulder of the tire on the tread side of the belt. And then inside of the tire press, there is an antenna. And that antenna is what emits and receives the signal from the sensor and then communicates with the reader, which does the data analysis and provides a temperature to the press that can be used for closed loop control. In this case, you have actual curing to a cure state of the tire rather than simply a one-size-fits-all cake baking kind of recipe cure where you cure to a time temperature that captures all possible initial conditions and tires, which actually costs the manufacturer money because they're spending more time than they need in the press. Okay, now we'll move on to the next technology. It's called an eddy current thermometer. This eddy current has been used in the past to measure temperature, but I'll explain why this one's better and different. But as far as the components, again, similar to RFID, there's a reader, an antenna, and the sensors in this case are simply a slug of a highly conductive metal, or it could be the object itself. We prefer copper or aluminum because they give the strongest signal, or alloys thereof. And then you have a host computer. Okay, again, why should you care? Why not just use RFID? In this case, again, this sensor can be read remotely through even more conductive material. Multiple thick layers of stainless steel or non-magnetic metals are easily penetrated by the low frequency, and this time a much higher signal strength than the microwire sensors. As I said, the sensor could also be the object itself. A clad cooking pan with an aluminum layer, which is typical between stainless steel layers, can be the sensor. Because the sensor is just a piece of metal, it's inexpensive and also can withstand extremely high temperatures. In this case, some features. This system is not a process sensor. This is a one-time calibration upon installation, and the sensor can be moved and replaced, and you will get accurate temperature. The thing that's different about this eddy current thermometer than prior art systems is that the measured temperature is independent of the antenna to sensor distance. It's pretty accurate, and again, because there are a lot of samples taken once per second on the polling rate. Basic theory here is that we're measuring a voltage response that's caused by the induced eddy current magnetic field, which then generates an induced voltage in our receive coil of the antenna. That voltage signal has a known dependence upon the bulk conductivity of metal, which, if you know the metal that you're using for your sensor or the object, has a well-documented dependence upon temperature, and thus we deduce the temperature. And finally, an example application. Because we can read through multiple layers of stainless steel, we have customers that are working on systems to read, for instance, a sensor that's inside of a pressure vessel, or a pipe that can't have a fitting, a puncture fitting, which is something that's eventually a failure point. This can also have a handheld reader that could read such a sensor that's permanently inside of a pressure vessel or a pipe. And that concludes my talk, so thank you very much. And TSI has licensed these technologies in certain fields. We're looking for more licensees, so thank you.
Our next and final speaker today is going to be Todd Hansen from Honeywell.
Thanks for everybody's participation that's on the call. What I wanted to go through is just a little overview on just industrial wireless design considerations. Again, my name is Todd Hansen. Honeywell has been involved in wireless for over 17 years. Started in home and buildings controls and in thermostats, in security systems that migrated into the process industry with what has now evolved into ISA 100 mesh networks. And the sensing and control group, of which I'm in, we participated in the ISA 100 and have some products there. But about 5 years ago, we started looking into point-to-point wireless, specifically for industrial type applications. So just going to kind of go through some of that, and we'll see here if the slides work, and it actually does. So I wanted to first of all go through a couple of key application considerations. What we've had released product solutions for approximately 3.5 years now, and the interesting thing is, from an application standpoint, the number one thing that we've heard from our customers of a value of going to a wireless type solution is wire and connector integrity. And a couple of examples here. One of the bigger ones, and what we're seeing a trend is in machine tool applications or machine applications where you may have wire flex. Specifically in machining centers, years ago, a lot of people used proximity sensors and went to proximity sensors. And what we're seeing now is a lot of applications where they're going to wireless because of not an issue that they're having with the prox sensors or any of the devices themselves, but it is with the wire itself due to wire flex and or the cutting fluid, which is carrying away the chips that abrades the wire and then causes problems. And so it really comes into a downtime issue and a productivity issue where wireless is adding value. The second one is one that probably comes to mind first when people think of wireless. They think of, well, it's a cost savings because you're eliminating the cost of the wire. That is true, and in some cases where there are long cable runs, or in the process industry where you have to run everything in conduit and you have to get certifications, there is a substantial cost savings to do that. But it's less of a value here than it really is in the first one, which was the integrity of the connectors and wire. And the third one, what we're finding is a lot of times when the product or the project schedules are tight, or in retrofitting applications. And I'll talk a little bit more on specifics on the retrofit. But with wireless in general, it's a lot easier to do retrofits after the fact than having to come in and pull more wire if you have to do it through conduit, or do the interface into the PLC and rewire cabinets. It simplifies things greatly there. Now,
okay, Todd, if I could interrupt you just for a second here, for those people who, the attendees who may be having trouble listening, but they're having trouble with their computers, we apparently have had a go to a webinar temporary crash problem. But we are recording the webinar, and we'll send out the recording in a day or two for those who have experienced problems. Sorry about that, Todd, but I'll give it back to you again.
We all have to adapt to change. So a lot of the questions come in, why the growth of wireless in industrial? And really what we've learned from Honeywell in being in this is it's a lot of key things here, but it is reduced wiring complexity, eliminating the wire and connector integrity issues, electrical isolation challenges. That's mainly on if you get into transportation like electrical boom trucks and cranes and things like that. Fewer tripping hazards. We have applications where they have to do temporary setups where they normally would have wire running across or cable running across the ground, specifically in oil and gas, and there's issues with tripping or slipping hazards. With wireless, you don't necessarily have to do any trenching or breaking concrete. If you have a facility that maybe you're doing, in automotive, when they do change-outs every year from model year, they may reconfigure some of the plants. It eliminates some of that requirements of having to relocate the control wires. Simplified troubleshooting. If you do have an issue with continuity or a wire's cut, you don't have those issues. And you're not tethered by the wire. We get quite a few applications where it may be on a moving part, or it may be something where the machine is torn down and put back together at another location. We have applications, and quite a few of them, where we've seen customers mount the wireless device using C-clamps, duct tape, and even Velcro. And the reason why they do that is because they want to be able to move it, a week later or 10 days later or whatever it is, and reconfigure. Lower cost on especially the long wire runs, and in some cases it can be applied where traditional devices just weren't feasible or possible at all. And especially for the design engineers that are listening, if you're looking at considering wireless, I just want to share some learnings that we've done, especially over my 5 years involved in this, but Honeywell's basically 17 years, is from a reliability standpoint, suggest that you look for solutions that have device diagnostics built in, such as signal strength, battery strength, those kind of diagnostics, and also look for a self-healing network. What I mean by that is something that does retries. There are especially networks out there that may be energy harvesting or based on energy harvesting, and some of those that are piezoelectric, basically you're relying on a spark to generate the single signal going through. If you miss the spark, then you're not going to get a retry. If there was a signal, it's lost forever. So you may want to look at something that there is some logic in there that if for some reason the receiver doesn't receive a signal, that there's got to be some validation 2 ways that it retries. From a security standpoint, look for standards-based encryption. We have gone with an IEEE 128-bit encryption for that reason, and it also, I'll skip a little bit, you need to understand the difference between security and interference. If you look at Wi-Fi, traditional Wi-Fi networks, when you talk about security, you're mainly thinking about, well, is somebody going to hack into it, or is there problems with somebody getting in and doing something to my system? If you look at an IEEE, and especially on like an 802.15.4 WIPAN type network, you're really not considered with the security piece of it. It's more of looking at the interference that you may have with other potential devices that are on a similar type frequency. So you need to look at that. And the middle one here is, if considering Wi-Fi, especially in industrial type applications, be very careful. Early on, we thought we were going to look at Wi-Fi type applications because Wi-Fi's networks are everywhere and they're relatively inexpensive. The challenge you run into is control engineers. If you're a control engineer, you're going to want to have total autonomy and control over your network. If you go to Wi-Fi, then the IT department is part of that, because they're looking at the overall infrastructure from an IT standpoint. And so you get into a battle between, well, who owns the network? And right away we had a lot of plant managers and facilities people and things like that that said, oh no, we're not, we want to control it, so we do not want to have something that goes into the enterprise network. Foolproof, easy to commission, should be setup tools, diagnostics, everything should be intuitive. And then the other thing is, not all wireless is the same. Recommendation is, if you're looking at some wireless solutions, try them out first and prove them out in your applications. User-friendly, should be automatic field pairing. You should be able to get diagnostic information. You probably need to look that the frequency of the wireless is globally license-free, especially if you potentially are shipping or sending your product or your offering to various parts of the globe. A key here too in consideration is, just because it's globally license-free does not mean that you can necessarily just implement it everywhere in the world. As well, there's a handful of countries out there that require country-specific certifications, and it's not RF-based, it is product-based. So just a consideration to look at there. So whatever supplier you're looking at, you may want to ask what licenses they have. It should be configurable to interface with any standard control you have or controllers, and then you want to look for something that's low power. On the rugged fit for tough applications, consider the trade-offs, because there's wireless out there that are wireless interfaces, basically like I/O interface. Consider the trade-offs between using something like that and having to package it for harsh duty applications versus things that are already packaged as harsh duty. So you want to kind of consider those. Consider the EMI, EMC requirements, and in almost all cases, I would recommend that you require test data from the supplier. And look at the sealing and the temp ratings for the field devices. On cost complexity, again, if you're looking at wireless, there's really kind of two types to consider, and that is either a mesh network type or a point-to-point. There's benefits to each. It's dependent on what your application and what you're trying to do. If you have a large facility where you're trying to cover a large area and you have multiple I/O around and you want redundancy, then mesh network may be the best option there. If you don't require necessarily the redundancy and you're looking for kind of a lower cost solution, and you're going into, in most cases, a PLC type controller, a point-to-point may make more sense. And then keep in mind here who sees the highest value. What we've found is sometimes the machine manufacturer may not see the highest value in wireless. It may be the end user. And so going forward, the end user, especially on that wire integrity, the connector value, they're going to see that. But if you are an OEM machine builder or selling to an end user your product, keep in mind that wireless could be a differentiator of your product versus your competitor in selling to your customer.
Great. Well,
and I'm getting a little bit of a delay here, but for some reason, let's try it again. So there you go. Oh, it jumped ahead. If you could go back one, there you go. So just a little pitch here on the Honeywell. Our point-to-point solution is referred to as Limitless. So we have various switch solutions that are wireless, including an operator interface. We have two different receiver options. One's meant for a kind of a one-to-one type relationship and is more meant for single machining centers and or vehicle type applications. And then we have what's called the WDRR receiver, which is a DIN rail mount receiver that would go in a control cabinet and would interface into any brand PLC or PC control. You'll note here that a lot of these devices are switches. We purposely started with switches because our devices are battery powered and switches don't necessarily consume power. We are looking and have some solutions coming out on the sensor side as well. And then the last slide, just a couple of installations here. What we're seeing is on safety showers, we're having a lot of retrofit applications where they do not have power and or control wires run to the various safety showers or IBAS stations, and it's very easy to retrofit and put some kind of a wireless solution for monitoring whether a safety shower has been actuated. On boom trucks, there they want to get around, they've got two things, and one is slip rings. They want to eliminate the number of points that they have in slip rings and or they're running out of points. And so wireless is a good solution there. And the other one is electrical isolation, that they want to eliminate as many wires as possible. And I mentioned machining centers. A lot of the machining centers is just to get rid of that problem with connectors and or wire flex.
Great. Well,
okay.
Thanks.
And thanks
you for that update, Todd, there in the wireless area. And now we're going to open up and answer the questions that we received. If you haven't already asked a question, now would be a good time to get it in the queue. but we do have a few that we can start off with right now. The first one actually is directed toward Brian there. Since you presented two temperature sensing techniques, the listener wants to know, what is the temperature range for each?
Okay. The eddy current thermometer has really the limits on the upper end, or the melting temperature of the object, and the lower end would be the fracture point of whatever piece that you're using at the coldest temperature. I mean, it is a piece of metal, so the conductivity versus temperature is in virtually of every known alloy is in every engineering book that you could go find. So that's all we need to be able to give you an accurate temperature. As far as the microwire sensing system, it's a little different. It is an amorphous wire, and therefore we have a limit on the upper end of 600 degrees Fahrenheit. Above that temperature, the amorphous wire will eventually begin to crystallize, and then we lose the magnetic properties that we need for that sensor. On the lower end, we could go lower than what we have now is -20 F, but we haven't had any applications that would need that. So hopefully that answers that question.
Great, yeah, I think that gives the person some insight in those particular areas. The next one involves USB, so this is yours, John. Are the USB devices dedicated devices, or are they universal?
Good question. Actually, we can support both. We have the capability to take any of the USB devices, match them up with a specific sensor, set them up and perform system calibration where the device is then matched to the sensor indefinitely, and I would say probably the majority of our users prefer that because it's going to be a dedicated set. However, for the universal user where they might want to swap out sensors, within the software, within our Sense-It software, we have the ability to scale the USB device for any given sensor where you have the flexibility to change out your sensors periodically depending on the test you're doing.
Great. Okay, here's another one. Looks like this one's for you again, Brian. Are you currently licensing the eddy current thermometers?
The eddy current thermometer is we're in a 2.5-year development project at the moment with a food service company, two different food service companies, one that's about ready to license in the food holding area, and another that's not quite as close, but it's also in a different food holding area. But outside of food holding, which, if you saw our slides, has been our historical area, we don't have any other licensees. We're looking, we're beating the bushes, so looking for people that are interested.
Okay, well, hopefully you got some of those people maybe listening today. Todd, as the last presenter, is a question for you there. What types of special testing does Honeywell have they done to document the reliability of wireless in industrial type applications?
Well, there's several special tests that we've done, outside of normal EMC, EMI, sealing tests. Probably the first, it relates to my comment about interference, because we get a lot of questions of, well, if you have multiple devices going off, being actuated at the same time, is there something that happens to the signal? So what we've done is gone through and put up to 15 systems, which you're looking at 15 systems times 14 devices, and we actuated all of the devices simultaneously and did that over a full test for like 3 weeks, about once every 10 seconds. And from a reliability standpoint, we came out at 99.97 reliability. So the question on kind of crosstalk with other devices, whether it's another 2.4 gigahertz radio or whatever, we found that, and we have the test data to show that that's reliable. Another one is we had a customer that was worried about electrical interference, and we did an outside lab test where they submitted our device to what's called a lightning test, and they hit it with 720 kV, the device itself, and during the test they are actuating it to verify that you're getting a signal. And so we have the test data on that. We also have a video available of them doing the physical lightning test, and the wireless device communications worked all the way through the test, and even after the test the antenna was melted due to the lightning and because of the electrical current that was going through, but the device still worked. So it's proven to be very reliable under some pretty harsh duty applications. But again, that test data is available upon request.
Well, that last one was pretty impressive.
Yeah.
Yeah, we're on a roll here apparently for you, Todd. Here's another one there for the wireless technology. Did Honeywell utilize wireless in large injection molding facilities like phosphoric acid, phosphate fertilizers, those kind of major production facilities?
We have, from a Honeywell standpoint, yes, we have. That's been mainly on the mesh network side. We are doing applications now on the point-to-point side. We will be releasing an intrinsically safe version, especially if you're in the fertilizer manufacturing. But we will be releasing an intrinsically safe version of the wireless later this year, which is probably more in tune with that. But, you know, from a chemical standpoint, you know, where we use all corrosion-resistant type applications, either stainless steel or plastic for those type of applications. One of the bigger ones we have is aluminum processing, where they're processing the bauxite. And we have quite a large application there, and that one's around safety showers.
Great, okay. Sharing the wealth, John, here's one for you. Are there alternative options if a user doesn't want to use your software?
There certainly are. In addition to the Sensit software that I mentioned earlier, we also provide support for the programmers. So on our website we have libraries for the Visual Basic programmers, and we're also very supportive of the LabVIEW users. So on our website as well you will find examples and libraries that support LabVIEW. So that allows the user really to have you know, some flexibility, either using our Sensit software or going their own course, or possibly, again, a LabVIEW environment.
Great. Brian, here's one for you there. How do you work with your licensees after the license agreement is signed?
Well, that depends on the licensee. We've had some licensees that we've been basically a contractor, some usually free hours as part of the license, and then paid hours after a certain point, so that design creep doesn't keep us employed without pay for 10 years or so. And then other licensees, we download in a few weeks the information, and they're off and running. So it just depends, but we're open to both.
Great. Okay, Todd, here's another one for you. What are some of the more interesting applications that you've seen where people have justified wireless devices?
Well, when you ask on interesting, they're all interesting because, especially with wireless, when people look at trying wireless and testing it out, I swear that they choose the worst possible and toughest application they could ever find. Probably the two most interesting is in one application. It was for looking at valve position out in the Florida Everglades, and they needed to go out and monitor that valve periodically to see if it was open or closed. And they evidently had to draw whoever had the short straw to go out in the alligator-infested area to check on these valves. And so what they did is installed a wireless device where they could do it somewhat remotely. The other one that's interesting, and I've had actually 3 applications come up And when I talked about wire integrity, normally on wire integrity, I'm looking at somebody cutting the wire, driving over it, or the traditional wire flex. But we've had 3 different applications where the main problem with traditional wiring of devices is because of rodents or rats chewing through the insulation on the wire and then shorting them out or losing continuity. And so the main reason they're going with wireless is to eliminate the problem with the rodents.
Interesting. So 2 justifications that I would have never put on my list there for switching to wireless: alligators and rats.
Rats, yeah.
Okay, I think we got time for just about one more question here. John, this one's for you. Can you comment on the type of true accuracy that that a user can expect to see using USB?
Absolutely, and no alligators or rats here. Our performance specs for all USBs, when it comes to accuracy, 0.001% of the respective full scale. So as I mentioned earlier, we look at the performance of these devices, and they are well beyond and exceed the performance specs of the sensor. So again, 0.001% of the rated full scale is typically what you're going to find on all of the FUTech USB devices.
Great. Well, that's going to conclude our webinar today. I'd like to thank all of our speakers for participating and giving us some great input in a number of areas. I'd like to thank our sponsor, MTS Sensors, there, and like to thank all the people who have attended this there. And a note one more time there that the webinar will be available on designworldonline.com and through an email. Again, you can tweet through hashtagging #DW webinar, and you can connect to Design World through Twitter, through Facebook, through LinkedIn, through YouTube, and we welcome you to discuss topics we've had in this with the engineeringexchange.com. So again, thanks to everyone, and till the next sensing webinar is on there, this is Randy Franks signing off.
Very good, thank you.